In this video, we're going to talk about the Spearman's rank correlation coefficient, and we're going to compare it to the Pearson. So let's get started. First, let's just do a reminder of when do we use the Pearson's regression or the Pearson's coefficient correlation. We're going to use it when we have a linear situation. So when we see data increasing, and when you look at the graph, it looks like it's forming a straight line. So this is when we're going to use Pearson. So you look at this example on the bottom, the data seems to be going in a linear trend. We could be drawing a line of best fit, which is a straight line. And in fact, when you run the Pearson regression, you get a Pearson correlation coefficient of 0.97. Remembering that the closer you are to 1, the more perfect your correlation is. So this is when we're going to be using Pearson. It is only used for linear relationships. Now, sometimes our data is not linear, but we still want to know if there's a certain correlation between our two data points. So an example of a graph that seems to have a correlation but is not linear is the one we see at the bottom here. So there seems to be a trend line possible to describe these data points, but it's definitely not going to be a linear one. Same as this graph, right? This one seems to be wanting to go exponentially, but the straight line wouldn't describe it to the best of its potential. So when we have situations like this, and we want to know if there is a certain relationship or correlation between our two variables, we're going to be using what's called the Spearman's rank correlation. So this is when you have nonlinear data and you want to see, is there a certain correlation between them? So the Spearman's rank correlation coefficient is labeled as RS. So this is the coefficient. So for Pearson, we had R with a P as a subscript, and when we're doing Spearman, it's going to be an S as a subscript. And it measures the strength of the correlation between data sets that show a monotonic trend. Now, a fancy word to say, basically your data is moving towards the same direction. So you could be increasing, which seems to be this case, or maybe a slight decrease in this situation. But there's a trend in which your data is moving together. So that's what we're going to use the Spearmans for. Now, there's some great advantage to Spearman's over the Pearson, and the first one being that it's a lot less sensitive to outliers. So if you have some outliers, the Pearson one is really affected by that, but Spearman is less affected. And of course, as we've been repeating time and time again, it can be used for non-linear data. In order to understand the Spearman's coefficient, it is very similar to the Pearson one. So whenever we have our coefficient being equal to 1, then we have something that is perfectly, strictly increasing together, -1, perfectly decreasing together. And if we have a coefficient close to 0, then nothing really is going on. There's no correlation possible between our two variables. And then the closer we get to 1, closer we get to increasing, the closer we get to -1, decreasing. Now let's do an example to understand how we're doing the Pearson compared to the Spearman. For this next section, you're going to have to use your calculator. So pause the video and go get your calculator. So the population of black bear on a particular island has been recorded over 5 years since 1978. Here is the data. And for part B, calculate the Pearson product moment correlation coefficient RP for this data. Okay, remembering how to do this in your calculators, you're going to go into stats and you're going to edit your two lists. You might need to delete data, so you're going up, you're going clear, enter, and you're doing the same thing for your other list, clear, and enter. And now enter all of the data. For Pearson, we enter the data as we see, list 1 for years since 1978 and list 2 for population. Once you have all your data put in, we're going to go into stats, calculate, and we are running a linear regression, which is our fourth option. Enter. Our X list, which is our years, is in L1. Our Y list, which is our population, is in L2. And we don't have a frequency list, so we can delete that. And we can go and click calculate. And now it's going to give us the A and the B. Notice that right now, my linear regression did not give me my R value. If your calculator did not give you the R value, then you need to format the calculator so the diagnostic is on. Okay? How you turn your diagnostic on? You're going to go and click on Mode. And in your mode, you're going to have Stats Diagnostic. So if it was off Stats Diagnostic, I want you to go and turn it on. So going on the on and clicking Enter. Once you see that it's on, then you can quit this page. To quit this page, second function, Mode. And now we'll go and run that regression again. So stats, calculation, our fourth option is a linear regression, list 1, list 2, and we can calculate. And now we have our R value. So we have the R squared and the R. So to answer our question about what is the RP, we're going to have the value 0.85. Actually, if we round it to 3 significant figures, we're going to have 860. So 860. Oh, apologize for this. So rounding to 3 significant figures, 0.860. Now, next up, find the ranks for each variable and draw a scatter diagram for each rank. So for each rank, I'm going to create a separate table such that I can rank each of the variables separately. The first one is fairly straightforward because it's already in order from smallest number to biggest number. So our first rank is simply 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right, so that was an easy one. And now we need to rank the next one. So what we have to do is we have to look for the smallest number, and our smallest number here is 1030. Our next smallest number is going to be this one. Then our next smallest number is here, and then we go on as such. Our next smallest number after this is our 33,000, but now we have to be careful because we have 35,000 something, which is bigger than these numbers. So our next smallest number seems to be 34,018. Then we go for 34,079, and then we have our 8th and our 9th value. So these are the ranks for our part C here. So finding the ranks. Once we have the ranks, we're going to be able to do a scatter diagram in our calculators. So please don't do this by hand, but do it with your calculator. In order to see our list 1 and our list 2 in a scatter plot, what we're going to do is we're going to go ask our calculator to graph it. Now, there's a few steps that we need to do before we click on graph. First, the graph button is an automatic for y equals to something. So if you have a function already in here, make sure you clear it so that nothing is in here. Next, we're going to go and we're going to want to do the stats plot. So second, y is equal to, is going to bring us to the stats plot option. You're going to click on the first one, so where the cursor is already at, enter. So plot 1, we need to turn this on. So I'm going to go and click on. So now it's on. Notice we have different types, so I can ask it to do a scatter plot, a line graph, histogram, box and whisker, and so on. I'm going to keep it to the scatter plot. My X lists are in L1 and my Y lists are in L2, so I'm good to go. Now, when you click on graph, it's possible that you see absolutely nothing, and that happens often. So when this happens, you have to think automatically, what is my window? What is the scale of this graph? So if we go to the window right now, we see that the X numbers, which are the number of years we have, is from -10 to 10. Well, that's not good for us because we have x's all the way to 40. So I'm going to go ahead and change my y maximum to something a little bit bigger than 40. So let's say 50. And then I'm going to go and do the same thing for my y's. My y scale now, the smallest y value I have is 1030. So maybe my smallest y value can be 1000. While my biggest y value could be something like 4,000, so that I encompass all of my data here. Okay, now that we have a window which is more appropriate, we're going to go back on the graph. And now we see all of our data points. L1 is our x's and L2 is our y. So now when we're looking at this graph, it's a lot easier to see that this data doesn't seem to be linear. So probably using the Pearson moment correlation coefficient wasn't the best option for us. So let's continue this question. And now instead, they're going to ask us to calculate the Spearman rank coefficient correlation. Okay, so for the Spearman, we did already our rank. Sorry, I'm skipping ahead here. So we already did our ranks. So we're going to go ahead and put this in. So we're going to go in stats, edit. Feel free to put the ranks in L3 and L4. So my first row of ranks was 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then my second row of ranks, make sure that you put them in order. So we have 1, 2, 3, 4, 5, 8, 7, 6, and 9. Okay. Now we're gonna want to find the Spearman's rank coefficient correlation. So we're going to be running a linear regression still, but instead of doing it with the raw data, we're going to be doing it with our ranks. So we're going to go back into stats, calculate. We're still doing a linear regression, but this time we don't want the raw data, which is in L1 and L2. We want the ranks, which are in L3 and L4. So notice that L3 is the blue on the 3 button. So we're going to go second, L3, and then we're going to go down and second 4 for the L4. And we're going to go ahead and calculate. And now we see that the Spearman's rank coefficient is actually 0.933. This is a lot higher than our Pearson one. So when they ask us the question, which correlation coefficient is most appropriate to use and why? Well, we're going to want to use the Spearman because we have an R value, which is a lot higher as our first reason. And the second reason being that when you're looking at the graph, well, we see that this is not linear. The last question, describe the correlation between the variables. Now, it's very important to realize that Spearman doesn't tell us what type of correlation is between the two variables. We don't know if this is a quadratic, an exponential, trigonometric. We don't know what correlation it is. But we do know that there is a strong correlation between them in an increasing manner. So again, we don't know what type of correlation, but we do know that they're increasing together. Sometimes with our set of data, there's going to be a tie that happens. So for example, if you look at this data, we have 3, 5, 6, 6, 8, and 11. Well, when there's a tie that happens, what we're going to do is we're going to average the two positions, and we're going to attribute that rank to both of these numbers. So what do I mean by that? If we would go ahead and start ranking, well, we would have, this would be our first rank, our second rank. These two have the exact same value. So since it's the exact same value, they should have the exact same rank. Technically, we could have this one being our third and our fourth. But now, since both of these data are the same, we want it to be the average of these two ranks. So when you average 4 plus 3 divided by 2, you get 3.5. So we're going to attribute the rank of 3.5 to both of these values. And then we continue with our ranking system. So we've used 1, 2, 3, 4. Our next rank would be 5 and 6. One easy way to check if you've done it correctly is your last rank number should also be how many data points you have. So here we have 6 data points. Our last rank number is in fact 6. Let's look at example 2 together. And in example 2, we're going to be asked to calculate the Spearman's rank coefficient correlation. So our first step is going to be to rank each of the set. Now we've done the first set already, so let me put what ranks we found. And for a second rank, we're going to go and always in increasing order. So our smallest number is 2. And then we have a three-way tie. So we have 1, 2, 3 fours. Okay, so let's think about what number we want to associate this to. Well, technically, this could be our second, third, and fourth rank. So we're going to need to find the average of these two. So we have 2 plus 3 plus 4, and average, we're dividing it by how many we have. So divided by 3. So we're going to attribute the rank of. So the average of this is 3. So that means that each of the values of 4 will be having the rank 3. Okay, next up, we've used 1, 2, 3, 4. Now we have our 5th and our 6th rank. Okay, so that was our first step. Our next step is to input the data, only the data of the ranks. So in your calculator, we're only going to put the ranks in, and then we're going to run our linear regression. Okay, let's go to our calculators, and we are going to go and edit our lists. So if you want, you can clear each of these lists. So by going onto the list number, clicking clear and enter, so we can start all over again. Okay, now we're going to put our ranks in. So I encourage you to pause the video and put your ranks in for L1 and L2. Once you have your ranks in, then we're going to go on stats. We're calculating a linear regression. We put our ranks in L1 and L2. So second function L1 and then second function L2. And we're going to go ahead and calculate this. And we get an R value of 0.585. So this is going to be our Spearman's coefficient correlation. Not a very strong one, so probably indicating that there is a very weak correlation between these two variables. Our next example is as follows. A student was asked to rank 9 different makes of burger in terms of which she liked best to which she liked least. She put 1 for the one she liked the best and 9 for the one she liked the least. These rankings and the costs of the burgers are given in this table. Explain why you cannot use Pearson's in this example. Well, the reason why we couldn't use Pearson in this example, even though it could be linear, is because one of our variables is already a rank. As soon as one of the variables is a rank, in which we have all the individual ranks, we have to use Spearman for this one. So as soon as there's a rank, Spearman. B, find the Spearman's rank correlation coefficient for this data. Now, for the first data point, the ranks are already done for us. Next, we have to do the ranks for the other cost. So pause the video right now and do the ranks for your cost. So what I did is I started with the most expensive item being my rank 1, and then I went in decreasing. If you did the other way around and you started with your least expensive as your number 1 and you went to more expensive, that is completely okay. Both will give you a similar Spearman's rank correlation coefficient. However, one is going to be negative for decreasing and the other one's going to be positive for increasing. So absolutely fine if you did the reverse that I did here. To calculate it, we're going to put in the ranks only, so not the raw data, but the ranks in our L1 and L2. If that's not done, then you can pause the video. And then we're going to go and do a stats calculation in which we are calculating L1, L2, and we should have our R value being 0.8. If you had it again reversed, then this number probably is going to be negative 0.8.